Welcome to the video, Chapter 7, Triangle Inequalities. This is Lesson 2 about the exterior angle theorem. This lesson essential question is how are the interior and exterior angles in a triangle related? Well, let's first identify what the exterior angles and remote interior angles are. The exterior angle is an angle on the outside of the triangle when you extend one side. So we can see here that we have triangle GFH, but we've extended this side GH to now create two angles here. And this angle 4 is the exterior angle. It is on the outside of the triangle. The remote interior angle are the two angles that are opposite to the exterior angle. So in this triangle GFH, it would be angle 1 and 2 are the remote interior angles, and then again, angle 4 is still that exterior angle, so 1 and 2 are opposite of that angle 4. So let's take a look and compare an exterior angles to the remote interior angles. So in this problem, it says the measure of angle 3 is 50 degrees. So if I label that as 50 degrees, then because there is a linear pair here, that means that angle 4 is 130 degrees because I can take 180 and subtract 50. So the measure of angle 4 is 130 degrees. Then also separately from that, we do have a triangle here. There are 180 degrees inside of the triangle, just like there's 180 degrees here in that linear pair. So as a general statement, if we look here, it says the sum of the measure of angle 1 plus the measure of angle 2. Well, if this is 50 and the whole thing is 180, then the measures of angle 1 and 2 have to be filled up with that 130 degrees that's left over also inside the triangle. So the sum of those two angles also has to be 130, the same as that exterior angle, because they're finishing off the 180 degrees inside the triangle. So angle 4 is finishing off the 180 degrees from the linear pair, but the sum, if I add together angle 1 and angle 2, that's finishing off the 180 from the triangle angle sum theorem, which is that there's 180 degrees inside of a triangle. Let's do it again, same setup, but in this one now, measure of angle 3 is 70 degrees, okay? Well, if measure of angle 3 is 70 degrees, then because that's a linear pair, measure of angle 4 is going to be 110 degrees. So we take the 180 and we subtract 70 degrees. Now, inside the triangle is 180 degrees. 70 of them is over there in angle 3. Angle 1 and 2 we'll need to take care of that other 110 degrees. So a measure of angle 1 plus the measure of angle 2 also equals 110 degrees. So this is the second time we changed the measure of angle 3, but it's the second time, if you look, this exterior angle has the same value as the sum of these interior angles that are opposite of the exterior one. So these remote interior angles, their sum is equal to that exterior angle. And that's exactly what the exterior angle theorem states. The measure of one exterior angle of a triangle equals the sum of the remote interior angles. And in addition to that, or going along with it, the measure of an exterior angle is greater than the measure of either remote interior angle. So that exterior angle should always be bigger than either of those remote interior angles individually. So let's now use the exterior angle theorem to find missing values. In this particular problem, we're asked to find the measure of angle 1, which is right here. Now, I could have given you this problem in a previous chapter, and I actually might have, where we used a couple steps. We would use a linear pair to find this value, and then we would know 2 out of the 3 angles inside the triangle, and we could find angle 1. The exterior angles theorem just allows us to really use a shortcut that the 52 degrees plus the measure of angle 1 will equal the exterior angle of 134. That's what the exterior angle sum theorem says, is that we take the exterior angle, and it is equal to the sum of those remote interior angles. So all I really have to do is take 134 and subtract 52, which gives me 82. So the measure of angle 1 is equal to 82 degrees. So this one, we are finding the value of x. X is an exterior angle. So I know using the theorem that the exterior angle is equal to the sum of the remote interior, which in this case are 65 degrees and 90 degrees. So I can add those together, simplify that right-hand side of the equation in this case, 155. And then I can divide both sides by 5, so x will equal 31. Now I'm not putting an angle, a degree label on this because x does not represent the measure of the angle. It is simply the value of the variable. If I wanted to know the measure of the actual angle, in this case, we would have to do 5 times 31, which should be, of course, 155, because that's what these two angles add to. This final problem takes it a step further, where we need to find the value of x and also all of the angle measures. Now the diagram itself is only labeled with numbers in the angle locations. We need to make sure we are labeling all of this properly. So the measure of angle 1 is 9x, the measure of angle 4 is 5x minus 5, and the measure of angle 3 is 3x plus 20. And this is important because we need to recognize that 1 is the exterior angle with the 4 and 5 angles as the remote interior. So we're going to be allowed by the theorem to set 9x equal to the sum of 5x minus 5 plus 3x plus 20, because that's what the exterior angle sum theorem says I'm allowed to do. So I'm going to go ahead and solve that equation for x. Now that we've got x equal to 15, we can plug in that 15 everywhere that there is an x and find those missing angle values, which gives us 135 degrees down here at angle 1. Angle 4 will be 70 degrees, and angle 3 is going to be 65 degrees. And we can use that information then to figure out the measure of angle 2 by taking 180 minus 135, and then we can do 180 minus 70 over here to find the measure of angle 5. So what I'm going to do is I'm going to list all this out. So just to keep myself organized here, the measure of angle 1 is 135 degrees. We found the measure of angle 4 to be 70 degrees, the measure of angle 3 to be 65 degrees. And then, like I said, if we take 180 and subtract 135, there we can find the measure of angle 2 is 45 degrees. And then if we take the 180 and subtract 70, again, this is because there are linear pairs here, then I can take, I can get 110 degrees there. I'm also going to take a second here to point out that angle 5 is the exterior angle to 2 and 3 being the remote interior angles. So if I add angles 2 and 3 together, the 45 degrees and the 65 degrees, they should be equal to the measure of angle 5, 110. And that does work. If you add 45 plus 65, you do get 110 degrees. So that would just be using the other exterior angle that's identified in this diagram. And that concludes the lesson on the exterior angle theorem. So how are interior and exterior angles in a triangle related? The sum of the remote interior angles equal the measure of that exterior angle.